Okay, stoichiometry involves a balanced chemical equation in which you use the coefficients in front of the substances to make ratios, and you can calculate the moles of reactants or the moles of products produced depending upon the situation. So we're going to take a look at example number 2. Okay, example number 2 in the chapter handout has this for your balanced chemical equation. Okay, so the underlined numbers are the coefficients, and they stand for moles. So I have 3 moles of hydrogen reacting with 1 mole of nitrogen to produce 2 moles of NH3, which is also called ammonia. Now, if I want to know how many moles of NH3 can be produced from 0.23 moles of N2, I suggest you put a question mark moles underneath NH3 because that's what we're going to solve for, and then put 0.23 moles underneath N2 so you know what it is that you're beginning with. Okay, now we're going to set this up in a grid the way that you're used to. So 0.23 moles of N2 is going to go in the upper left hand corner like this. Since I'm starting with nitrogen, we're going to use the coefficient in front of nitrogen on the diagonal. So we're going to write 1 mole of N2 on the diagonal like this. Okay, and that number 1 came from right here. And then we're wanting to solve for moles of NH3, so we put the 2 in front of NH3 on top as 2 moles of NH3. So it looks like this. So this 2 came from here. Okay, so now what we're going to do is we're going to multiply 0.23 times 2, and then you divide it by 1. So 0.23 times 2 is 0.46 moles of NH3. And you're done. That's it. Okay? All right, let's go on to example number 3. We have 2 moles of sodium reacting with a mole of chlorine to produce 2 moles of sodium chloride. So it looks like this. And we want to know how many moles of sodium chloride result from the complete reaction of 3.4 moles of chlorine. So we're going to write 3.4 moles underneath chlorine because that's what I'm starting with. We're going to put 3.4 moles of Cl2 in the upper left-hand corner like this. We have a 1 coefficient in front of Cl2, so we're going to put that on the diagonal because I started with chlorine, so it needs to come down here. So this 1 mole of Cl2 will go on the bottom. And we're solving for NaCl. So we're going to put this 2 moles of NaCl on the top right here. You're going to multiply 3.4 times 2, which is going to give you 6.8. And if you divide it by the 1 on the bottom, it's still 6.8. So your answer is 6.8 moles of NaCl, which looks like this. Okay? Okay, now, if you turn the page in your chapter handout, you're going to notice that there is an unbalanced equation at the top of the page. Okay, so this is your opportunity to show me that you learned something in Chapter 8 on balancing chemical equations. So we're going to write out C2H5OH plus O2 yields CO2 and H2O. So it's like this. Okay, so we need to have the same number of each type of element on the reactant side and the product side. So I've got 2 carbon here, so we're going to put a 2 in front of CO2 to balance the carbon. Then you'll notice, in terms of hydrogen, I have a total of 5 plus 1, which is 6 hydrogen on the left-hand side. So you should put a 3 here because 3 times 2 will give you 6. So now you have this. Now I told you to balance oxygen last anytime you have this O2 by itself. So here I have 2 times 2, which is 4 oxygen, plus 3 oxygen right here. So 4 plus 3 is 7. You already have 1 oxygen alone here. So if you put a 3 here, 3 times 2 would be 6, plus this one would be your 7th oxygen. So that's the equation balanced. And you use this to do number 4 and number 5 in the chapter handout. So number 4 says determine the number of moles of oxygen gas. So I'm going to put a question mark moles underneath oxygen gas required to burn 1.20 moles of ethyl alcohol, which is C2H5OH. So I'm going to put 1.20 moles underneath C2H5OH like this. Now we're going to set up the grid. Which looks like this. We're going to put 1 mole of C2H5OH on the diagonal and 3 moles of O2 up on top. If you multiply 1.20 times 3 and then you divide it by 1, you're going to get 3.60 moles of O2. And that's your answer. Okay, now, number 5, how many moles of CO2 are produced? So we're going to use the same balanced equation. So I'm going to put a question mark moles underneath CO2. How many moles of CO2 are produced by burning 1.20 moles of ethyl alcohol? So we're still using the same quantity of ethyl alcohol. So we're going to put 1.20 moles of C2H5OH in the upper left-hand corner. And then I have 1 mole C2H5OH on the diagonal and 2 moles of CO2 up on top. So it looks like this. Okay, this 2 is now here. Okay, 1.20 times 2 is 2.40 divided by 1. You still have 2.40. And that's it. Okay. Now you're ready to do the worksheet on mole-to-mole conversions. It looks like this. Okay, there's a front and a back. Now, you have to write out the balanced equations on some of them. Okay, so make sure you have the periodic table that has all of the nomenclature tricks on it. And then make sure you watch significant figures. The number of significant figures that you start with is the same that you'll have in the very end for your final answer.